Hello and welcome to my shop. My name is George and I'm coming to you from Chelsea, Quebec. Now this video is a replacement video for 3 earlier ones that I published on the horizontal mortiser. The problem with those earlier videos is that I kept changing the design as I moved along. So in the first video I thought that this was a great design, let's publish it, and then in between, I realized that there was a mistake or two, an improvement that needed to be explained. So I published a second video with the improved way of adjusting the height. And then I encountered more problems, so I published a third video, again correcting some of the omissions of the prior two. And lately I've been working on a fourth video to correct some of the earlier not so much mistakes, but things that needed to be just finely tuned and adjusted. And I said, oh, this is silly. I can't keep stringing people along with improvements in a subsequent video and one after that and one after that. So I said, okay, let's scrap the whole thing and publish one video with the final product. There may still be minor improvements coming down the line, but I don't think they're going to be large enough to justify yet another video. So let's get going. This slide shows you how to get to the place where the OpenSCAD and .stl files are located as free downloads. Pause this video if you need to jot anything down. So let's start with the router and its components. The router itself that I'm using is a DeWalt trim router. It's a corded model, and the model number is DWP611. Its critical feature, I think, is the diameter of the core, 69 millimeters. So if you have a trim router with a similar diameter, you might be able to just go with the components as they are. The router is held with these braces. The braces themselves can be printed 5 inches in, we call that the length, I guess, or 4 inches in length. What I like to do is use a combination. The 5 inches gives me better stability, but the 4 inches gives me more travel here side to side. The upper and lower sections are held together with bolts. They happen to be 1/4 20, so that's an imperial designation. 1/4 inch, 20 threads to the inch. The upper access is for nut drivers, so you can actually fit a nut driver into these holes to hold onto the head and to turn it. Underneath, there are 6-sided openings for the nuts, so they keep the nuts from turning when you want to tighten or loosen these braces. Now, the front brace sits in a frame. So the frame is just wide enough for the thickness of the brace, but it has a lot of side-to-side opening, a large side-to-side opening. It's 7 inches. So with 7 inches of opening and a 4-inch brace, that gives you up to 3 inches of side-to-side movement, and that will correspond to the length of the mortise. I really doubt that I'll ever need a mortise longer than 3 inches in length. So I think this arrangement will suit me without modification for a long time. The stops are very simple. They're bolts, again, 1/4 20. And in the on the inside, there's a nut that sits in its own little chamber. The chamber keeps it from rotating, and so you can rotate the bolt to shorten or lengthen the opening, and when you're happy with its location, you can lock it with the butterfly, and that'll set the stop for the left side of travel. So that takes care of the top side of the router platform. Let me show you what goes on underneath. So underneath we have this green printed item here that I call it the truck, and here in yellow are tracks. So the truck with its half round cylinders over here ride along the tracks forward and backward. The truck half rounds and the track half round hollows are 6 inches apart. So here's one pair 6 inches apart, but here's another set 1.5 inches over from that, and a third set 1.5 inches over from that. So the router can travel here, or if I need to be a bit to the left of that, I can travel here, or if I need to be yet again to the left of that, it can travel there. So tracks for the router run along here, and they also run along there. So I can position the router in 3 different slots on this side, or 3 different slots on that side. So putting it all together, what would go on with the router, of course you've got it plugged in and you get it running. The workpiece would be here. You would plunge in a little bit. Now this sort of bit doesn't let you go in much more than about 1/16 of an inch, but you would plunge in, slide over to the left hand stop, and then pull out. Come back to the right hand stop, plunge in. This time you'll be able to go a little deeper and go over and out. Always plunging into the right end of the mortise, traveling across left in the left direction, and then coming out again. I'll explain later why it's important to do it that way. So let me say a few words about the area that holds onto the workpiece. It starts off at the bottom with a base. It's Baltic birch, and it has been crisscrossed with dovetail channels, specifically for the match fit clamps that Microjig makes available. So the match fits can be positioned anywhere along these channels, and they can hold down a workpiece pretty well no matter where it is. The base also has these 3 cylindrical things. In this country, let's just call them what they are, 3 little pucks. And what they do is they position the ramp. Now, the blue thing, I'm calling that the ramp, and the yellow thing that has the same angle as the ramp, I'm calling this the platform. So no matter where the platform is positioned along the ramp, the bottom of the ramp and the top of the platform remain parallel. But by putting the platform, say, down here, the overall height is small. And if we position it up here, the overall height is tall. So with the position of this, we can adjust the height. The ramp can fit onto the pucks like this, or like this, or like this, or like this. So if it's in this orientation, then height adjustments are referred to the router coming at the thing from over here. If I arrange it like this, then the height adjustments are for the router coming from this side. So one more component to talk about. Attached to the platform is this blue L-shaped fence. So it's going to serve as the reference location for the workpiece. Now, I also have here a previous version of the platform, and I'm going to make something a little bit smaller and less wieldy. But what I'm doing with it right now is parking it behind the actual platform, and it serves to mark the place of the platform. So if I remove this and do something with it and then bring it back, I know exactly where it belongs. Probably this won't be moved if I'm doing a series of, say, 4 mortises and identical workpieces. But on the chance that I do have to move it and replace it, I'll make something smaller than this that can just be slipped in behind the platform, or maybe even in front of the platform, and mark the location. So here's the platform in place. Here's a workpiece, and we can bring in the clamps. And we're ready to go. So we can make the mortise for this first piece. And then for the second piece we'll just slip into the same location. So let me tell you how this design came about. Some of it came about from those 3 a.m. Percolating cauldron meanderings that just come up when you're lying awake in bed, not really asleep, not really awake, and how to repair the earlier flaw is the problem of the day. And then you come downstairs, you print the new version, you test it out, and sure enough, it's fixed the previous problem, but it's created 2 more of its own. So, back to the drawing board. So some of the design comes from that. But there is another source, and that was you. Some of the suggestions and comments that I received from the earlier 3 versions of this video were, well, not game-changing, but design-changing. I incorporated many of those suggestions. Still, those earlier videos had to be taken out back and burned, and in the course of getting rid of them, that meant that these precious comments also disappeared. So it's too bad that the comments couldn't somehow live on. Okay, so what about the comments? Well, the first one that caught my attention was from Josh Walker. And he said, "I love everything about it except the height adjustment." And that echoed my own feelings about that very first design. The adjustment of height using shims was tedious. So I replaced that method of adjusting the height with some smooth ramps. So basically 2 wedges with a smooth interface between them, and as they slid past each other, the height between them would change. Okay, now Mark, in your inimitable, gentle way, you wondered whether the smooth ramps had any problem with slippage. And they did. I had to develop a new kind of muscle memory in order to bind the ramps together. Did I hold them gently and then firmly as I clamped down, firmly and then gently? And even with that, even with practice, one time out of every two, as I was clamping them together, they would slip back a little bit. So yeah, you saw the problem. And I think others saw the problem too and went right to suggestions that would get around the problem. Now, one of the suggestions was to replace the smooth ramp with a staircase. And the idea there is if you've got a staircase, it won't slip back. You know, if you imagine yourself standing on steps and suddenly you become twice as heavy as you are, you're not going to fall down the steps. You're held in place because you're standing on level ground, even though the levels change up the staircase. So I'd love to be able to thank you by name for that suggestion. I went looking through the comments and couldn't find it. So maybe you retracted it. I can't thank you by name. I'll do the next best thing, which is the standard YouTube way. You know who you are. Thank you. So a staircase. I went scrambling to find my calculator, and I worked out for the dimensions that I was working with at the time. I worked out that a run of 2/10 of an inch combined with a rise of 8/10 of a millimeter would give me the kind of resolution and range that I needed. And that's the wonderful thing about being a Canadian woodworker. You get to work with the best of both systems anytime you want to. At around the same time, I got a comment from Keith. Now, Keith, you may have heard about in earlier videos. He has recently finished a gorgeous kayak. He sent me some photographs, and they're going to be the subject of a forthcoming video. So stay tuned for that. So Keith made a comment as well, and his suggestion was why not put a vernier scale on the ramps, and that'll help you refine your position. And that was an intriguing suggestion. I needed to think on how a vernier scale could be implemented. And in the end, so I applied it to a model of the staircase from the earlier suggestion. And the way I implemented it was by putting notches. So on one of the ramps, the staircases were identical on the two ramps. So on one of the ramps, I put a notch every 5 steps. On the other ramp, every 9. And sure enough, when I brought them together, one pair of notches would line up, and I would move it a step, and that pair of notches was no longer aligned, but another pair of notches would line up. And with each and every step, except one almost unique pair of notches would line up. So that became viable, but I was working on the problem of refinding positions in a different way at the same time, and I ended up using the other method, not the vernier scale. But Keith, I had great fun working out how to implement it and then watching it work in the model. So thank you for that. Now, Stephen Zello. Where did the saw teeth come from? Well, that was Stephen's suggestion. he suggested maybe using an increment a little bit like the way Incra does it with saw teeth. Because with saw teeth, whether you're a little shy or a little proud of the actual mark, the sides will just guide you to find the bottom of the V's in both cases. And so you get a lock on precisely the same location every time you find this, the same two valleys in between the notches. You have truly reliable precision in all of these steps. So that was what led to the final way of having the ramp get adjusted. Now I used the same numbers as for the staircase. In other words, 2/10 of an inch for the runs and 8/10 of a millimeter for the rises. And it worked beautifully. I verified things with a pair of calipers. So I would bring the two ramps together, so the ramp on one hand and the platform on the other, bring them together and measure their distance. Then I would move one step, and the distance changed by 0.8 millimeters. And I would move another step, and it changed again by 0.8 millimeters. It was unbelievably faithful, and that in the end is the design for adjusting the height. So thank you, Stephen. Now, for those of us in North America, what is 0.8 of a millimeter? Well, it's very, very close to 1/32 of an inch. So if you are stepping a 32nd of an inch at a time, and you're trying to match the height to a pencil line, the most that you can be off is a 64th of an inch, okay? If you're a little high or a little low, let's say you're exactly midway, well then that's going to be 1/64th of an inch away from your pencil line if your step sizes are 1/32 of an inch. So even if you didn't make a suggestion for the design, the comments that I received from you that were supportive were deeply appreciated. So comments like, I'm going to make one of those too, or nice design, or well thought out video. Yeah, that's happened occasionally. Or even nice tie. These are all comments that go to making me enjoy publishing YouTube videos. So thank you for those. And I'm thinking specifically now of Keith Der Schlatter. Now, I hope that's not a proper name. If it is, I'm sorry if I mispronounced it. I'll tell you what, have a go at mine. Timothy Hood and Woody Wood. Woody, we go back a ways, don't we? These comments just encourage me to keep on making YouTube videos. It's still a very fun thing to do. And it might be that woodworking is just one of these corners of the internet that collects nice people. That could be so. Okay, so let me just wrap up what this section was all about. It was explaining how the design came about, and much of it came about from you. So, thank you. So I'm sure you noticed the little dance that I was doing with this routing, and that was that I would come to the right, enter, move to the left, and exit. And then I would come back in air, not in the mortise itself. Again, plunge as far as it would go, move to the left, and come out again to retrace my steps back to the right end of the mortise. And this is a procedure that I recommend. What this kind of bit will let you do is enter and then go back and forth with a zigzag pattern, plunging in a little deeper every time you go from left to right or from right to left. And that is not recommended. What I recommend, especially for the larger bits, is to enter at the right end, move to the left, and then exit. For the next pass, come back to the right, staying in air. Plunge as far as it'll go, which is not very far because this kind of a bit doesn't have a blade that goes right to the center. And as a result, it'll only plunge about 1/16 of an inch, maybe even less each time. So again, to be not worrying about being a little bit redundant, you go in as far as you can at the right end of the mortise, with the mortise spinning, of course. Move to the left and then exit, come back in air. Now, why do it that way? Well, as long as the router is spinning, and if you're staying in one place, then when you plunge, there's no tendency for the bit to either rise or fall. But you do have to take into account where the bit is biting and where it's coming through with less of a bite. Okay. So imagine that you're traveling from left to right. The bit is spinning like this. So if you're traveling to the right, the upper part of the bit, or in other words, the blade that is at the top will be biting more than the one at the bottom. Okay, this is true while you're moving the router. It's the bit that's now reached the upper position that's going to be biting into the wood more than the one that is at the bottom. And that's going to give you a tendency of causing the router to rise. On the other hand, when you're traveling from right to left, now it's when the sharp bit is at the bottom that it bites more than at the top. At the top, it'll be relatively in open air. It's at the bottom where it's really meeting new wood for the first time. And so while you're actually moving to the left, the tendency will be to nose down. Now, the router is against a very stable platform below, so it's going to resist nosing down. But as far as up goes, when you're traveling from left to right, if you've got the bit in the wood biting, that's going to give rise to making the nose go up, and there's nothing other than gravity keeping the router in place. So it will have a tendency to rise, which puts an added meaning to a climb cut. So for that reason, for the stability of it, I recommend always, when you're actually plunging and carving into new wood, is to make sure that your movements are to the left and never to the right. So always come back into open air to move the router back to the right. The recommendation is probably less important when you're using the smaller bits, and much more important when you're using the larger bits. Since you've got a trim router that you're using, they have 1/4 inch shafts, and so you can quite readily find 1/4 inch, 3/8 inch, and 1/2 inch bits. Anything larger than that you probably won't be able to find. So when you're using the 1/2 inch bit, it's especially important to follow these dance steps. When you're using the 1/4 inch bits, maybe it's less important, but I recommend the habit no matter what you're using. Well, thank you for sticking it all the way through till here. I hope, I don't know what I hope. So let's just cut it. Well, thank you for sticking it through till here. I hope this video was a satisfactory replacement for the 3 that I had to destroy. And remember, if you can make some time for your passion, that's great. But what's even better is if you can share it. Bye from me for now.